All right, here I am, straight from North Florida, talking about test one for Bio 1140. And test one covers chapters one, two, and three. And as you know by now, there's no time limit on test one. It's open book, it's open note. I assume that what you're going to do is open up your notes, open up your book, and maybe even get Google next to you, like on the Wikipedia or something, and spend some time working through that test. So you want to take your time working through it so you can get all the right answers. One thing I want to talk about really quick is the 20-point question. And like I said, if you guys got some questions, go ahead and shoot in the live chat over here, and I'll get to them as they come in. But let's talk about that 20-point essay question really quick. That 20-point essay question, it's basically there for you to talk about something you want to talk about. So what did you find most interesting? What did you find important? It can be anything. We're stardust, or we're connected to the universe, or chemical bonding. It really doesn't matter, what you choose to talk about in that essay. Just, tell me what it is that you find interesting, and then quickly explain it. And then about 10 points of that are go look some other information up. Just go to the web, make sure your information is accurate, and add to what I presented in the first three chapters. So try to teach me something cool. That's how I learned too, right? I got you guys out doing some research for me, because who knows what you're going to find that could be really cool. And that's, finding that additional information. That's 10 points. That's 10 points of or 10% of your entire test. So you want to make sure that it's not just a sentence or two. It needs to be about a paragraph. And the whole essay needs to be around 500 words or more, and make sure it's well written. So, spend some time editing it. You can have your roommate, your parents, friends, whoever help you edit that essay so that it sounds good. Just don't copy it from the web. That's so embarrassing when people copy this stuff from the web and I have to give them zeros. So just don't do that. But it is open book, open note. For those of you that have been taking the quizzes, the thing about the quizzes, they are timed at about 20 minutes. And the idea with the quizzes is I make them timed so that you can't just open them up and take them, and take several days to take them. You need to at least become familiar with the chapters. And those low stake quizzes help you become familiar with the chapter and familiar with the material. And then, like I said, when you go take the test, there's no time limit on the test. And if you can't get it in by next Sunday, that's not a big deal. You'll still get full credit for turning it in late. So the only hard date for everything to be due is, of course, May 9th, when everything is totally due for the whole semester. But don't forget bonus points, right? If you get quiz 1, quiz 2, quiz 3, I hear my child in the background. She's having I don't know what's going on back there. But if you get quiz 1, quiz 2, quiz 3, the syllabus quiz, and the opening survey, science and digital literacy, at least one done, and the test done all by Sunday at 11:59 p.m., you'll get 5 points. And then, this is a 16-week class, so there's 4 of these 4-week blocks. And every time you get everything done on time in a 4-week block, that's good. You'll get 5 bonus points. And if you get all of them done, you get an extra 5 bonus points. So you can get like 25 bonus points. That's like 5% of your grade can come just by getting stuff done on time. But if you get behind, something comes up, like I said, you're still welcome to turn in these assignments past the date that they say that's due. Another question that I've had is, people turn in the quizzes late and they're like, wait, this didn't get accepted. Yeah, it's accepted. It's just I have to manually grade them at that point, or manually accept anything that's turned in past a due date. And those due dates are there to help keep you in line, to keep you caught up with the course. And like I said, I'm presenting new material each week, but if you wanted to work ahead, that's fine. I don't care. If you get behind, that's okay too. All right. So really quickly, does anybody have any questions? Because if you do, shoot in the live chat and I'll do my best to answer them. But with the test, on this channel, on my YouTube channel, if you go to my live streams in the past, you'll notice that I've addressed a lot of the questions already about the material. And if you go to some of my previous live chats when I've introduced the material too, that helps out. And people have also asked me, they said, there's a lot to know. And this is biology in college, right? It's not high school. So there is a fair amount of information to know that's different than what you might be used to. But to take the test, get your book out, get that required reading out, get your PowerPoint up. That's going to be almost everything you need will be right there. However, some of us, we learn pretty well by watching videos and taking notes. So if you watch a video, take notes on everything. As you read through the chapter, take notes on it. And then also, I've got those podcasts. Sometimes we just need to be we can listen to our lessons as a podcast. And once you get a podcast, you can just hear the material. It's another way to immerse yourself in the material. Okay, so I can't see what I got wrong, but I did get 2 questions wrong, and I wanted to ask the right answer. Oh, I'm glad you like the podcast. Thanks. They get better as they go on. My first one was my first attempt, but I've increased my game as they've gone on. I'm glad you like them. So I got 2 questions about not being able to see the answers. I will double check on Learn as soon as I get off of here so that you can get your correct answers when you submit the test. I thought I had that set up. Sometimes me and Learn, well, it's Learn. We'll just leave it at that. We don't need to go down that road right now. But I will go in there and see if you can get the answers that you missed. And also if you you definitely need to go see that. So I'll see if I can get that fixed for you guys. All right. So you wanted to ask for the right question, the right answer. Well, if you know which questions you got wrong, I'm happy to go over that with you at any time. Okay. Any other questions here about this material? Quiz 2 didn't give the answers. Thank you very much, Naomi. That's actually really helpful because now I know to go in there and just double check quiz 2 to make sure all the answers are up so that you guys can do that. So do you have any questions on the material itself? That's always important. Like, do you understand, the difference between facts, laws, and theories? That always seems to get people tripped up a bit. Do you know what a hypothesis is and what a hypothesis is not? Like, I hate the term educated guess. So it's not an educated guess. Make sure you understand how we science, right? We call that the scientific method, and what it means to be significant, what a significant difference is, and whenever we do a test. These are things that you'll want to know about. And then in chapter 2, make sure you know those themes in science, like, what is life, or what does life do? What is an emergent property? Know about natural selection, evolution by natural selection. These things are important. And then when you get to chapter 3, something that a lot of people really find that interesting is when you realize, like, we're made up of elements, and elements are made up of these subatomic particles, protons, neutrons, and electrons. And those were created like in the Big Bang 13.8 billion years ago. And then the elements like hydrogen and helium were formed basically right after the Big Bang. And then, well, you and I and all living organisms, we're 96% carbon, nitrogen, oxygen, and hydrogen, which has been around since the beginning of time. But we also have calcium and magnesium and iron and sodium and chlorine. And all of those elements were created inside of stars. I know that's wild, isn't it, to think that the oxygen inside of you and the carbon in you was once inside of a star. So we are seriously stardust. And I think a lot of people find that interesting. But these subatomic particles come together to make the elements. And then very importantly, elements are held together by chemical bonds. And for most of our molecules, it's these covalent bonds that hold, like carbon and hydrogen and nitrogen and oxygen together. And that carbon is that element of life because it can form 4 of these chemical bonds called covalent bonds with other elements. And you can create millions of different chemicals. So, that's important to know those chemical bonds and that carbon is the element of life. And then I just recently made another video on water and why water is an important ingredient of life in terms of it providing a chemical medium for all of life's chemical reactions to occur. So these are things that you'll want to make sure that you know well. I don't have a glossary. I don't even have defined terms anymore. I've kind of gone to the point where I feel that it's very important that when you read a section or a paragraph and you come across a word you don't know, almost every one of us has one of these things. Cell phone. Mine's pretty beat up. You can see all the cracks on it there. There's an app. It's called Wikipedia. You can Wikipedia almost any word you don't know, or Google any word you don't know. That's why I don't have a glossary and all these defined terms in the book, because it should be up to you to realize what you don't understand. And that's kind of metacognition, right? Knowing what you don't know and then going to look those words up. Yeah, is the test open notes? You bet. Yeah, it's open anything. I don't care. Go take the test. Go take your time on it. Use your notes. Absolutely. Read the chapter, take notes on it. Watch a podcast, take notes. Watch a YouTube videos, take notes. Organize your notes. Test is open anything. There's no time limits. I'm not going to put you on respondus. That's pretty creepy if you ask me to have a video on you while you're taking a test. I wouldn't do very well. Which practice problems in the reading are you referring to for the test? The practice problems are posted in each of the, so you have a learning module. Let me see if I can do this for you guys really quick. I can share it. Oh, I'm in the wrong program. I'm on YouTube. What you can do is go into each week, and let's say week 1 is chapter 1, and you have instructional material. Those practice problems are basically as a docx file. There's the Word file of those practice problems, and they're not required, but I put them there for you guys to work on those questions. And many of the test questions come from those practice problems. But like I said, if you want to do well, you'll do those practice problems. And I don't provide an answer key, but if you have any questions about the practice problems, I'm here. You've got the online learning assistant, OLA, Liz. She's there for you. So don't hesitate to reach out at all if you've got any questions about those practice problems. I'm happy to go over them with you. All right. Well, I didn't have a real spill or anything to give you guys. Just wanted to make sure I could answer any of the questions you might have, as some of you've opened up the test and taken a look at it. And if there's any concepts or anything that you need some clarification on, I'm here. All right. Nobody's got any questions. Let me ask you guys a question, and you can hit me up in the live chat if you want. How many of you were confused about life being an island of low entropy? That's what I said in one paragraph, in one section, when I was talking about thermodynamics. I said, life is this island of low entropy surrounded by a sea of chaos. And then later on, I go on and I say, no living organism is an island. Somebody was okay. See, if you're confused, feel free to ask these questions if you're getting confused about that stuff, right? Definitely ask, because I had a student ask me this question earlier and today, or actually I had 2 students ask me that, and I was like, everybody's confused about this, and I have no idea, because I keep asking if there's anything that people don't understand, and I get blank back. So let me explain this one a little bit for you guys. So an island is basically something that's isolated, right? So let's talk about an island of low entropy. There's a lot in that statement that you need to understand. First of all, you have to know the word entropy. Entropy is a measure of disorder. So the higher the entropy, the more disordered something is. I'm gonna all right, guys. All right, there's all my camera gear, recording gear, and everything. I'm in my childhood home here. I drew that picture back in high school, and there's my microphone. And as you can see, not everything's in order. That would be high entropy. I used to keep my room in a more or less state of high entropy, much to my mom's chagrin, right? And so it's disordered. So if you don't go and clean your room or clean your house or clean your kitchen, it becomes more and more disordered, chaotic. And that's actually steady. And the universe is trying to go toward this steady state of high entropy. So don't clean your house, entropy increases, it becomes disordered, which is actually stable. Living organisms are organized. We have low entropy. So I'm a living organism. I'm a system. I'm surrounded by my skin. This defines me as a system with all these chemical reactions that are taking place inside of me every second of every day of my life, and they are organized. I am organized. Well, at least my body is organized. I might not be organized in general, but I've got 200 different cell types organized into different tissues, organized into organs, organized into organ systems, all controlled by my brain, which is organizing everything throughout my body, right? So a living system is ordered. It has low entropy. So if I say I'm an island of low entropy, I'm surrounded by air. The air molecules in this room are moving in complete random motion. That's why there's no breeze in here. It's completely random. That is high entropy. So I'm an island of low entropy because as a living organism, from cells all the way up to the largest animal on the planet, we are living systems, we are ordered, and we are surrounded by high entropy. Okay? So the air molecules around me, like I said, there's not a single breeze. They're all moving randomly, and they're moving really fast, like 600 meters per second. But you don't feel that because they're hitting you randomly. And in fact, they exert about 14 to 15 pounds of pressure over every square inch of your body. Now, the next question is, I said, no living thing is an island living in isolation. And when that's from an ecological point of view. So if you think about this, life is an open system. Now, remember, a system is all of these reactions or moving parts or parts that are interacting together, right? And that system occurs in a defined space. So a living system could be a cell. It could be a plant. It could be me. So once again, here's the boundary of my system right here. But I am an open system. I just ate dinner before I hopped on YouTube, right? So I have an input of energy and I had an input of nutrients. So my body will take all the foods I ate, break them down, transfer that energy to ATP, and then I'm breathing out carbon dioxide and water as a waste and get rid of the other parts of the waste. You know how it's done. So I'm an open system because I've got energy and nutrients, materials constantly coming in and exiting. And in fact, you and I, we're 98 degrees right now. So a lot of the energy that's stored in the food we eat is radiating, is exiting my body. So we're open. Energy comes in, energy exits. It flows through us. So life requires that constant supply of energy. So in that way, no living system is an island, because if you don't have a constant flow of energy, you cut life off from energy, life dies, right? So that's why life is not an island isolated by itself from an ecological point of view. And like I said, ecology is a function of how plants and animals interact with themselves and their environment, because every living organism has to interact with this environment to get nutrients and energy. So I hope that explains the two concepts of islands a little better there. Okay, how did that go? Is that good? Did that help out? Okay. Well, yeah, it's kind of hard, talking into a camera with not much feedback here, but okay, so why is life low entropy? That's a good question. Let me explain this again. Once again, let's think about, entropy. And the reason why I bring this up is because entropy has to do with these laws of thermodynamics. Thermo means like heat, dynamic means like a moving system. These laws of thermodynamics, they govern how energy works, right? And the reason why we talk about the laws of thermodynamics in biology is because life requires energy. There cannot be any life without energy, okay? I hope that makes sense. So the first law of thermodynamics and you can't create or destroy energy, but you can move it around. You can use energy. But the second law of thermodynamics says, hey, every time I use energy, I degrade it. It becomes less usable. And as a result, that increases our entropy. So life is ordered, because if we weren't ordered, right, we'd just be another chaotic system like the water or the air around us. So one of the things about what life does, one of the definitions that I talked about of life, or what life does, is life uses energy to create order. So let's say I just had a pasta dinner here with some salad, right? So what's happening, my body is taking all these materials down, breaking them down, extracting the energy from them. And let's say like I had some shrimp in my pasta tonight. I'm on the coast, I know, I'm eating shrimp. And I'm breaking the proteins down into their building blocks. And then I take those building blocks called amino acids and I build them up into the proteins of my body. That's why life is ordered. That's why life is low entropy. If we were high entropy, you'd be dead. You'd be in equilibrium with your environment. And you never, ever, ever want to be in total equilibrium with your environment, because you'd be nothing more than carbon dioxide, water, and some minerals. And that's it. So life is low entropy because we are in a highly ordered system. We're also an emergent property of all these chemical reactions that's creating complexity. Okay, looks like I helped out with somebody there. Thanks, Naomi. Anybody else have any other questions? Are we all good here? You're welcome. All right. Yeah, sometimes it's you have to hear these things explained several times. I mean, these are concepts we don't often think about. So I'm happy to always explain things several times over, because I've been thinking about these for a long time, and so it's easy for me. But it's not so easy the first time you're introduced to some of this stuff. So I'm glad you guys are asking those questions, and even if I have to explain it multiple times, it's okay. That's a really good question. I mean, it's the limitations of observational studies. When we do science, one of the hallmarks of doing science is we make observations, we ask some questions, and then we formalize our questions into these testable hypotheses that we then go out and we attempt to either refute them or support them. And the way we do that is by testing. And we can test our hypotheses by doing a direct experimental study where we manipulate the variables, and we might have a control in an experimental group, or we might do an observational study. So observational studies are another way that we go collect data. So let me give you a good example of an observational study and the limitations of it and the benefits of it, because that's I think a test question too. So an observational study, you probably have heard that smoking is bad for you, that smoking causes lung cancer. Smoking leads to higher rates of vascular disease, like cardiovascular disease. Okay, the reason why we can't do an experimental group where I take 10,000 people and make them smoke, and 10,000 people and I don't make them smoke, and then follow them for 30 years is because that would be totally unethical to do that, because that would cause harm to those people. So instead, what we rely on is an observational study. So in an observational study, we will follow the lives of people who smoke and record how much they smoke and for how long they smoke. And we will record the health and lives of people who don't smoke. And then what we realize is that, well, smokers on average live 10 to 15 years less than non-smokers, and they have higher rates of vascular disease and higher rates of lung cancer. And we know that the smoking causes lung cancer, even though we didn't do a manipulated experiment on that. In that case, correlation does equal causation, because we know that the pathogens, that the chemicals in cigarettes damage our lungs that lead to cancer. So the reason why we do these observational studies is because we can test our hypotheses when it might be unethical to do a large-scale experiment. Now, a big limitation of an observational study is, even though I just talked about this with smoking, is that you can't always get a correlation equal causation. Now with smoking, you smoke more, you get lung cancer, there's a causation because we know, even though we did not do a manipulated experiment, we know this because of the chemicals in smoke. We know that causes lung cancer, and we've actually studied that in our labs. But let's say another limitation of an observational study might be the Mediterranean diet. A lot of people are on a Mediterranean diet now, and they say that leads to better health outcomes. So once again, you follow lots of people on a Western high fat, high sugar diet, people on a Mediterranean diet, and you come back after 20 years and say, hey, people on the Mediterranean diet lived longer. They had less rates of obesity and all the other problems associated with being fat. And you come back and say, okay, this Mediterranean diet is the reason why. The limitation here is we do know in part the diet is incredibly important, but people that are on the Mediterranean diet, if you didn't actually manipulate the diet, they could be walking more. People on a high-fat McDonald's diet might be walking less. And walking might be one of the most important things that people do for longevity. I mean, this is just an example, right? People on the high-fat American diet might be drinking more alcohol. They might be smoking. They might be sedentary. So there's all these other things that might be affecting longevity that you didn't control when you were testing your hypothesis about the Mediterranean diet. So that's a limitation of observational studies, because the correlation, eating Mediterranean diet, lower body weight, is not always equal to causation. It may not be causing it. Now after I just used that as an example, Mediterranean diet is actually pretty healthy for you. It is good. Here's another example of a observational study where correlation is not equal causation. It's one of my favorite ones. I think I talked about this. Global climate change is caused by a loss of pirates. So as the number of pirates has gone down, global temperatures have warmed. There's a correlation. The correlation is clearly spurious. It doesn't mean anything. It's an artifact. There's no way that pirates are affecting climate change. So, that's one of those limits of observational studies, is that you may get these correlations, but there's no causation behind it. One's not driving the other. Hope that answered your question there. Okay. Does anybody else have any other questions for me? If not, I'm going to sign off here. Okay, are we all good? Hey guys, thanks for the thumbs up, man. It's good to get some nice feedback. I'm going to say it again. I really miss being in class and getting to know you guys and being in a lecture. I'm not going to lie. I'm happy being here in Florida. You guys are going to get some seriously cold winter weather coming up this weekend. Oh my gosh. You guys are in for some polar vortex stuff, and I'm not going to get cold here at all. But I do seriously wish I could be in class with you guys, get to know you guys. And I really appreciate you guys showing up. Man, thanks for the thumbs up. Thanks for your questions. Like I said, don't hesitate to ask questions. And I got one more here. Why don't we try to prove our hypothesis? And I mean, that once again, that's a fantastic question. And in fact, in science, we often hear science is proven, science is proven, science is proven. Well, not so fast. We do prove facts. We proved the Earth is round. We did prove the Earth revolves around the sun. I mean, we've proven facts. But when it comes to proving our hypothesis, what happens is that there are many, many possible outcomes, and we can't possibly control for every variable and predict every single outcome. So what we try to do is actually disprove our hypotheses first. That's why we have what's called the null hypothesis, and then we have an alternative hypothesis, right? So here's a good example of this. And this, like I said, this answer is a little bit nuanced, so just bear with me. There's a global pandemic going on, and there's this new vaccines coming out. One of them is a Pfizer, one is AstraZeneca, one is Johnson & Johnson. They do a large-scale study. They do 23,000 people get a shot, 23,000 people get a fake shot. That's your control group. When testing whether or not this COVID vaccination works, a null hypothesis would be there is no difference between your control group, the group that didn't get any of the vaccination, and your study group that did get the actual vaccination. That's no difference. They both get the coronavirus at the same rate. Your alternative hypothesis, you can have two of them. One is it has a lower rate of getting infection, and the other alternative is it has a higher rate of getting infection. Now, what we do is we go out, and the reason why we were able to get the vaccination done, approved so fast, had nothing to do with rushing the science. Well, they did rush it, but not in a bad way, not in like a reckless kind of way. The way they were able to get it done so quickly rather than years is because the coronavirus is so contagious. They were able to get enough data in a matter of months by the very nature of the coronavirus itself, rather than taking years. That's why this vaccination is safe. Okay. Now, what happens is they go out and they collect the data from the control group and the experimental group, and they look to see the infection rates. It turns out that like the Pfizer vaccination after the second dose and 2 weeks after the second dose, it had a 95% reduction in COVID cases. That's astoundingly good. That is good. And but some people that got the shot actually still got sick because vaccinations aren't 100 proof. Not all of them are 100% effective. 95% is fantastic though. But because one or two people still got it, we didn't prove that it works beyond a shadow of a doubt. It just we were able to refute the null hypothesis that that there was no difference. We were able to show that there was a difference between the control group and the experimental group, and that difference was significantly different. Like that's at 95% different. And the other reason why we don't try to prove our hypothesis is because not only can we, it's nothing's or very few things are ever 100%, like getting these vaccinations are about 95%. And the other one, the biggie in science is we're all biased, right? I mean, every one of us wants to prove our pet hypotheses. Every one of us, we look for data to support our how we perceive the world. So I'm looking around for it. Oh, I'm gonna admit, you see that I drink these things. I have one every morning. I haven't gotten COVID yet. It must be my Monster Rehab every morning that's preventing me from getting sick, right? If I went with that anecdotal data and I said, oh, I proved myself right. What do you guys think? No way, right? There's no way. So the reason why we don't prove it, we don't try to prove our hypotheses, we try to reject the null and then accept the alternative, is because it reduces confirmation bias. It helps us reduce our own bias because, like I said, if I thought that this worked and prevented COVID, it does not. It just makes me feel good in the morning because I wake up stupidly early. Like I said, it's really, really important that we do science as objectively as we can and not look for biases. So you might pick up on information that, oh, I drank my Diet Pepsi today. I drank Monster Rehab. That confirms my hypothesis that this has antiviral properties. And of course it doesn't, right? So that's why we don't try to prove it, is we're really trying to prevent biases. Okay. Does anybody else have any other questions here? I'm going to sign off in a second. And these questions have all been good, so I appreciate it. All right, guys. Well, thank you. And y'all have a nice night. And I'll be around all week long. Like I said, if you've got a problem with the test or a test question or a quiz question or just not understanding a concept or just want to talk about some of these concepts or talk about some of the science you're learning, always feel free. I'm going to come on online on YouTube every Monday to introduce chapters. And like I said, feel free to hit me up with any questions you have. I'm happy to have a conversation. And you're welcome. I'm more than happy to answer your questions. They're good questions. All of you guys ask good questions. Never hesitate. All right. Well, you guys have a good night. Like I said, shoot me an email if you've got any questions.